All right, so try out this question as if this is your gate question. So you can't afford to lose marks in this with some silly thing, calculation mistake and something. I'm giving you few minutes, few seconds basically, maybe 1 minute and so. Try out this because you need to have a time constraint. So for a rocket engine, the velocity ratio is VA by VE. Velocity ratio, where VA is the vehicle velocity. I hope you people agree this VA for us is U, vehicle velocity. And VE is the exit velocity of the exhaust gases. So this is, I think you people agree, is nothing but sigma for us, if you recall, which was U by CJ. Correct? Here it is denoted as R, and in place of U they are saying VA, and in place of CJ they are saying VE. It's fine. Assume the flow to be optimally expanded through the nozzle. Okay. For R equals to 2, that means for this ratio 2, if F is the thrust produced and m dot is the mass flow rate of exhaust gases m dot means m dot P, then F by m dot VE is. I'll wait and I want you to ping me the answers. I'll remove each one of this. I want all of you to respond me on this. Tell me your answers, whatever you are getting, and then we'll discuss this. Very good, Akavya. Yeah, perfect. This perfect. Yes, Priya. Yes, Ravi. Mohit, think about this. You have already given the negative marks to, it means 0 marks because it is fill in the blank. You're not going to get any negative. But see what you are doing, or just think about this. Don't rush into this. They're simply asking thrust divided by m dot into V. Yes, Charlie Godats. Yes. Your thrust is m dot P into Cj, right? And they're asking what is F divided by m dot P into Cj. Simply tell me, what is this numerical? It's not numerical. I don't know why 1 by 2. Done, done. This is over. Optimally expanded nozzle. This exit velocity is nothing but Cj. This is m dot P. This is your thrust. This ratio is 1. This is 2 marks. Mohit, those who have given me 1 by 2. Why you have to use all the time the data which is provided to you? Makes sense? 2019 is a gift. If you read it properly, if you give 0.5, you are nowhere doing anything in the gate exam now. Because this is actually a gift numerical. It's not a numerical, it's just to check. They have given you this just to confuse you. It doesn't make sense anything in this numerical. You should know that thrust expression never depends upon U. And this is U by Cj. So it should never depend upon this quantity, right? Rocket equation or rocket is independent of its own velocity. You never have U term present in your thrust equation. Is this fine? Can I assume you people got this? Those who have missed this, no need to worry, but think about this. You need to read numericals very, very carefully. There is no equation which is not in your notebook. All the numericals should be solved from your notebooks only. Can I move ahead? Okay. Try out this. This is also 2019. Next question, question number 46. Think about this. The specific impulse of a rocket engine is 3000 Newton seconds per kg. Be very cautious. Okay. I'll again give you some time. The mass of the rocket at burnout is 1000 kg. So you know at burnout, the remaining mass is 1000 kg. The propellant consumed in the process is 720 kg. So propellant consumed is 720 kg. Assume all factors contributing to velocity loss to be negligible. Now this statement is very, very much clear to make it that don't consider any losses. So no gravitational losses. The change in velocity delta U in kilometer per second is. So delta U, you people know, is ISP into G into ln of M1 by M2. I need this in two decimal places. You know MP, you know M2. So definitely you know M1. That is M2 plus MP, and it came out to be 1720 kg. So you know this. They're simply asking in two decimal places. Tell me your answers here. This is correct, Priya. This is correct. Yeah. Kilometer per second, Ravi. So Shashwat, you have done exactly the same thing what they wanted you to do. Yes. Yes, Gavit. Just check the catchy part here. This is, yeah, this is the all of you have, Anjali, you have done the mistake. Mohit, I need in kilometer per second. You cannot write this. This is basically, if you recall, is thrust divided by mass flow rate of propellant. They don't have this gravity here. So ideally speaking, this is ISP into G, which is 3000 Newton seconds per kg. Or this is CJ. Yeah. So this whole quantity is 3000. If you check the units, right, ISP is in seconds, gravity is meter per second square, or to be very precise, this comes out to be Newton seconds per kg. You are using gravity again. Mubin, please tell me in kilometer per second. Guys, there is a reason of telling you again and again. The reason being you will write this as 1626 in your exam. So it's a fill in the blank question. Tell me in two decimal in kilometer per second. So your exact answer as per the key released is 1.60 to 1.65. This is the correct key. Anything 1.62 and 1.63 everyone is getting. But I want, please respond on this to me, guys. Is this part clear to all? This part, that this whatever they have given is basically CJ for you, ISP into G. You need to be very, very much clear in the units when you're seeing or reading the numerical. So 2018 was a gift, 5 seconds, provided you go slow and be very much clear in the basics. 2019, same question, next question 2045 and 46. See, it's also a very gifted question, but the units they have played in this. Those who have used will get the answers as something which some of you have already pinged me. Don't rush into this. This is a good topic for you to grab some marks in this, save some time, and then move forward. Tell me if this part is clear to all, guys. Is this fine, guys? Very much clear, right? So we have learned a lot during this solving numericals. You should take care of gravity losses. If it is not mentioned in the numerical, you need to be very cautious with the unit of what they are asking and what they are providing. And especially they are playing with this Newton second per kg impulse. Okay, try out this. This is ours in 2020. Again, I'll wait for some time, try to solve this, finish this, then we'll see 2021 and then the numerical asked in 2014, which is a lengthy question. A rocket engine has a sea level specific impulse of 210 seconds. So let me write the data. So you have specific impulse of 210 seconds and a nozzle throat area of this. So your nozzle throat area is 0.005 meter square. While testing at sea level conditions, the characteristic velocity and pressure for the thrust chambers are this and this. So I hope this is easy. C star is 1900 meter per second and chamber pressure is 50 bar. I think we know where we are getting. Gravity is given. Don't use at 9.81. Use it as 9.8. The thrust produced by the rocket engine is, fill in the blank. I want your answers in kilonewton, rounded off to one decimal place. I hope this is easy. From ISP, you people know you can easily calculate CJ. Your thrust is m dot p into Cj, and m dot p I think is coming from your characteristic velocity, which is p naught a star divided by m dot p. So 2020 was directly formula based, no catch involved. You know p naught, you know a star, you know c star. From this you can calculate m dot p. Once you know m dot p, you can calculate Cj from this. Substitute everything here. Tell me the final expression in thrust. 2020. Let me check the key for this. Anywhere you have doubt, just let me know. I think this is the gifted numerical. Please tell me your doubts if you have any. No, no, no. No, m dot p you're saying. I have not calculated in between. 27.1 kilonewton is perfect, Priya. They have given anything between 27.0 to 27.2 as per the official key released by IITs. 27.1 is the exact answer. Can you just help me with m dot p so that other people can have step checking? What is m dot p, guys? 13.15 kg per second. Okay. And then you can calculate thrust. This is the final answer, guys. So 2020 was literally gifted, and it's actually the easiest paper also as well. But all are easy, provided you read the questions easily, properly. Tell me if this part is clear to all. So answer is 27. I'm opening another PPT because I need to share 2021 question. All right, just give me 1 minute.